Thanks for calling in to office hours for October 25th. This will be a fairly open topic, office hours. Sen Huang should be calling in soon and can discuss any simulation related topics that you're interested in. I guess first quick, I guess I'll poll the audience here real quick. Are people interested in hearing about using simulation in conjunction with Volttron, specifically MATLAB and Energy Plus type simulations? And he can also talk to Modelica. Any takers on that topic?
Yes, please.
Okay. Okay, well then he should be getting on here shortly. While we wait, at the next office hours, Shweta will talk about some work that she's been doing to get Volttron data into Elasticsearch. So that should be a good topic.
Would that be the Volttron battery data? Building data.
Shweta, did you have any update on the battery work?
No, can you hear me?
Yeah.
Yeah, the testing is going on. It should be done in a week or so, and then we can share our findings.
Okay, so at next office hours, you could do Elasticsearch and the battery experiments.
Yeah, that is
okay.
2 weeks from. Yeah.
Thank you. All right, let me ping Sen again here. While we wait for Sen, any other questions or topics that people would like to cover? Any research that people would like to, that they're doing that people would like to share with the rest of the group?
Just a quick question on pull requests, and how would I go about providing a pull request, like minor pull request? Do I need to sign a license agreement, or?
If you could basically just send an email saying that you're fine with the license that is in the code, that would be fine. And then just go through the process of creating a pull request.
Okay, thank you.
Yep, thanks for asking.
And I want to know about the Volttron, between the Volttron and Energy Plus, how they connect each other. And then I want to know I want to see the result on the Volttron dashboard from the Energy Plus. So is it possible to see the result on the Volttron Center dashboard?
Let's see. While we wait for Sen, Shweta, do you know enough about the Energy Plus work to talk to that?
I know I can answer part of the question. So there is an Energy Plus agent acts as a go-between between the Energy Plus model and the Volttron. So it receives data from the Volttron, supposing that an agent on Volttron wants to control some set points on the Energy Plus model.
Could you get closer to your mic, maybe?
Yes. I cannot hear your voice. Yes, thank you.
So there is an Energy Plus agent that is responsible for moving messages between Volttron and the Energy Plus model. So basically, it receives all the set points from the Energy Plus model and publishes it on the Volttron bus. Similarly, if an agent wants to control the set points on the. Hello, can you hear me?
It's still pretty quiet.
Okay, I'm working remotely, so I can just be
Mm,
as I can. Can you hear me now?
yeah,
Yes, yeah,
that's
yeah.
better.
Much better.
Okay. So as I was saying that if an agent on the Volttron side wants to control some set points on the Energy Plus model, it uses the actuators API
Yes.
to control, and the Energy Plus agent receives those control commands and translates it into something that Energy Plus understands and sends it to the Energy Plus.
And if the data from Energy Plus is being published onto the message bus in the same format as devices, then it should get picked up and be able to be displayed on the dashboard.
Oh, okay, I see. Thank you. I will
Yeah.
try. Yeah.
And if you have more questions about that, then we can follow up in email.
Okay, I see. Okay, I will send you an email. Okay, thank you.
Okay, and then that might be a demo that maybe we could work with Sen to put together a demo around that.
Oh, okay. I really appreciate it. Is it okay to send the email to you?
Yeah, either send it to me or to Volttron at PNNL.gov.
I see. Thank you. I see
So,
the email. Yeah, in
yeah.
the chat. Yeah. Thank you.
Yep.
While we're waiting, Green had just one question and an update, and I just wanted to. I sent you an email earlier, but thanks for all your help. Our system's up and running, and it's talking to Voltron. One question on talking to the data in the historian. What
Mhm.
is in the past? You said that it's able to talk to a cloud like AWS. What is the best way to actually get that data out of the historian? Is that something that we pull from there, or the historian pushes out?
With interacting with AWS specifically.
Yeah, let's say AWS. If we were trying to get that data out of the historian into our AWS SQL database, let's say, could you kind of just do the couple steps in there to how we would actually pull that?
So you haven't, just to make sure I'm understanding, you have an outside process that is going to interact with the database, or is it going to go through the Volttron historian?
We could have an agent that could pull from the historian into our database.
Well, so the historian is just basically a front for a database. So if you want to interact with a database directly, then you could have the historian just store in that database, and then whatever process is going to be using that database can just do it directly. You don't have to pull it back out from the historian and then put it into another database.
Okay, awesome. Thank you.
Yeah. So and you said the database is SQL.
Yep.
Yeah. So for instance, we've had people who are doing visualizations based on a database, and Volttron, the historian, just pushes into whatever database, Redshift or SQL or whatever.
That's what we were curious. So it can push it out to that database. Perfect.
Yeah. So really, what the historian framework, what it does is it allows you to have a general way to get data off the message bus and store it into whatever storage solution you want, whether it's a simple CSV file or pushing it to another instance of Volttron or putting it into a database or sending it to some web service endpoint. So we even have done it through an MQTT endpoint for Azure in the past. So yeah, whatever you want to do to get that data stored, that's what you can do through the message bus.
Okay,
Or through
awesome.
the historian, sorry. Yeah.
Historian, yeah, perfect. All right, thank you so much.
Yep, no problem. And so the point with that is that you can create a concrete instance of a historian, and all you have to care about is how you store data, how do you retrieve data, how do you set things up, and then the rest of the plumbing is handled for you by the base class.
Awesome. You guys have made that very easy to connect.
Oh, thanks. Yeah. So Sen, are you on? Don't see him.
Hey, Jeremy.
Yeah.
It's Terry Hurwitz in Telemation.
Hey.
put a question out there while we're waiting. So I think a couple of weeks ago or months ago, probably, I emailed something about LoRaWAN into Volttron. And we're looking at how to do that. But I wanted to, it seems like our initial thought was we'd figure out a way to get the in-building gateway to talk to our in-building Volttron edge node. But that has some drawbacks. And so the other way is that the gateway talks directly to the cloud, you know, and then but it can, the cloud LoRaWAN can expose that as on a like an MQTT message bus.
Okay.
So my question is this: if we could, so we could probably get that data then into the Volttron in the cloud instance. And if I'm correct, any Volttron instance in the edge can subscribe to any other Volttron instance's topics, correct?
So you're in Voltron 5, right? So you're using ZMQ?
Well, yes, we will be.
Okay.
In this case.
So in ZMQ, yeah, you can have a Voltron instance subscribe to and publish to a remote Voltron instance's message bus. Are you in a situation where you've got a couple dozen and they each need to talk to everybody's message bus, or is it?
No, it's going to be more that, you know, like whatever. We have X number of buildings where we have a Voltron node that's collecting data from the BAS. And then we have in that same building, we'll have a gateway, a LoRaWAN gateway that will that will get its data to the cloud, the same place we have Voltron, another Voltron instance running, right? Voltron Central, another Voltron instance, which will get that data then in the cloud, not at the edge. But we want that box that's in that same building to have that data. So we would just ideally subscribe to it from the edge box, just the data that's coming out of its building, and get that from the Voltron instance in the cloud. And that would be times, you know, I don't know, 100 buildings. But it would only be, so each building would only care about the LoRa sensors that are in its building.
So you'd have one giant Voltron instance that is getting data from 100 buildings?
Well, so all of our Voltron instances go, you know, collect the data and push it to the central cloud.
Okay.
And that central cloud, in this case, Voltron instance would also get, would also be where all of the LoRaWAN sensor data would end up.
Okay.
I mean, I guess just the simple question is that if I can with any, you know, with a network of Voltron instances, you can subscribe to any other Voltron instances message topics.
Right. So there is some, depending how you do it, there is some setup that needs to happen. If you want basically a point-to-point, so I'm just going to start with our campus deployment here. So we have over a dozen collection boxes that are pushing data to the central instance's message bus because they've got the forwarder agent that's configured to do that.
Right.
They could also subscribe to that remote message bus and get stuff back if they wanted to. And there's a data puller is kind of the reverse of the forwarder. What the data puller does is it subscribes to a remote message bus and then republishes things locally. Is that what you're?
Yes, that sounds like that would solve the problem. Yes.
Okay.
Okay.
And
you call that a message puller? Is that okay?
Data puller? Yeah.
Data puller. Okay. Okay. I'll look that up.
Okay. Yeah. Let us know what you think. And then long-term maybe, so RabbitMQ allows you to do some interesting things. You could have well, Shweta, do you want to maybe briefly talk about RabbitMQ and how that would work?
Sure. With RabbitMQ, you can essentially have
And you're quiet again.
a campus deployment case again. So you have a central entity, central instance that is collecting data from each of the buildings. So you can have with ZeroMQ, we were doing that with forwarders running on each of the buildings and forwarding data from the local instance to the central instance. Now, we can remove the forwarder and replace it with shovels, which is essentially going to do the same thing for you. It's going to take the data from the local instance and push it out to the central instance. And the configuration is pretty simple, and we have easy scripts to do that. Federation is something else. So if you want to have a collection of instances that want to talk to each other or want to get data from each other, then Federation allows you to do that. So basically, if you have a set of trusted instances, then you can establish Federation with each other, and then any instance there can subscribe to messages from other instances, and it's able, with the Federation setup, it's easily able to receive those messages.
So that might be something to look into in the future.
Okay. Is the RabbitMQ is that in the current release?
That was the 6.0 release. So that's currently master. It's optional. You can still use ZMQ if you want to. But yeah, that's the current release. And then it'll also be in the 7.0 that goes out. That's in Python 3.
Okay.
So, and if you want to follow up and have a more detailed discussion of implications, then we can do that. Maybe get you and Andrew and whoever else needs to be on that call. Okay,
fair enough. We might, because we're definitely digging into this fairly deeply now to try to solve it.
Yeah.
Okay.
Well, and the hope with RabbitMQ is that that's a whole other project with millions of dollars behind it, and so we're hoping to leverage the capabilities that they are bringing to that in Volttron.
And I remember when we were discussing this video, I heard MQTT. So do you have an MQTT broker in the next year?
I'm not sure I understood the question, or I could hear it actually.
So when you were describing your deployment case, I heard MQTT as well. So do you have an MQTT instance in the cloud that is going to receive the data?
Sure. Yeah. The LoRaWAN gateway that we're looking at, and its network server can use MQTT, which seems to be almost ubiquitous now in terms of IoT message bus. And my understanding is that is just one of the options you can use with RabbitMQ, correct?
Yes, we have. So this year we tried the connection between an MQTT client and RabbitMQ, and we have an example out there that allows you to seamlessly connect. So you can try that out.
Okay, excellent.
Okay. Thanks, Sen. Can you hear me? He must still be getting his audio sorted out.
Hello, can you hear me?
Yep. Hey, there you are. Hey, thanks for calling in, Sen. So Sen has been doing a lot of simulation work in general, and then with Energy Plus and Modelica and other things in Volttron. Let's see. We had a couple questions on it. Maybe Sen, do you want to maybe just start with kind of an overview of the simulation work you've been doing, and then we'll see what questions people have.
Sure.
Thanks.
So let me share my screen.
Okay.
Can you see my screen?
Yep.
Okay, so this slide is created just to give some technical detail about how we integrate NPlus with Volttron environment. So the first thing, I just want to give a quick introduction about NPlus. So NPlus is a whole building energy simulation program. So it's basically trying to providing the long-term energy performance estimation for like a commercial or residential building. And it's basically providing all the details regarding, for example, how the building operates in terms of the energy consumption, and also how the building, like a service, respond to certain control. For example, how the air temperature in the building change when we changing the different control or changing the the different design of the building in terms of the connect system and also the envelope. And so this is basically the idea. So how we can basically couple the NPlus with Volttron. So the idea is that we're using the Volttron message bus as a buffer for the data exchange, and then we create like a Volttron NPlus agent, which talk to the NPlus software through the BSD socket connection, and then all the building information will be published into the Volttron message bus, and then those message bus can be basically used as like some information to mimic what you receive from a real building, so that we can do some like a closed loop evaluation of building control or other activity. And then from other agent, you can basically sending some command which basically trying to override the set point or building system. So it can be done in two different ways. So the first way is that NPlus agent having like the subscribe to certain message. So once you kind of publish certain like contraction into certain message, it will trigger the NPlus agent to override the, for example, the set point or the like a low level control action inside the NPlus. So then you can see how those kind of building operation will affect by the updating the control. Or you can send in the remote RPC command. So just like you, how you do that in the real building, you can send in, for example, the get point information or the set point command to changing the message or the command inside the NPlus agent. So that's the whole like picture. So the key for this kind of integration is really how to set up the socket connection. So in our case, we basically utilized one code simulation engine called the BCVTB, Building Control Virtual Testbed, which is the software setup developed by Lawrence Berkeley Lesson Lab. So the architecture for the BCVTB is showing in this figure. So what inside the dash box is the BCVTB. So the idea is that the BCVTB will having like two different components. One is called the actor, another is the server, the socket server. So the actor basically is having two functionality. The first one is really sending the system call to calling certain simulator, and then it will sending the configuration file in terms of how we can set up the socket server to the BCV C library, which is associated with the simulator. And then it will set up a server which can talk to the client within the TCP IP protocol. And then the socket client are able to basically talk to the simulator through the internal BCDB C library. So if we're using NPlus as the example, So Anyplot basically package the C library and also the client into a class called the external interface, built based on another software called the Ptolemy. This is kind of inside Anyplot. It's already kind of packaged into one component, so you can utilize with any kind of standard version of Anyplot. And then what happened is that PCODB was sending the system call to initialize the simulation. And then it will basically also sending the configuration file to define how, for example, the port for the TCP communication, and also what will be the host. And then once the simulation is running, the data will be exchanged in runtime through the TCP/IP protocol. So this is how the BTP worked with Anyplot. So in our case, we basically leverage the three kind of functions. First one is basically execute the system call to start Anyplot, and then we also utilize the configuration file function to basically customize the configuration for the Anyplot simulation. And then we also set up the socket server. That's the kind of three necessary components to start Anyplot in like a co-simulation mode. So what we did is that we first using the Python sub process library to enable Volttron to basically call Anyplot as the system call. And then we're also using the one Python function to write the configuration file automatically based on the up-level Volttron configuration. So that is basically writing, for example, the variable CFG file, which define what will be the input and output for the Anyplot simulation. And then this basically customized based on user input. And then we can also kind of write another configuration file to define the socket connection. After that, we basically set up the socket with the Python socket package. And then everything will be basically packed into one agent called Anyplot agent. And all the agent kind of is designed for generic purpose. So only kind of case-dependent variable will be the user input, which define what will be the input and what will be the output. And this is really how we can define the input and output. So the first thing is that in Anyplot, in the Anyplot agent config file, we first need to define the model. So where we can find the ideal file, which is the input for Anyplot, and where will be the weather, which is the major input for Anyplot simulation. And then we can also need to leverage the B2B source code to basically enable the communication. So those kind of three information will be utilized to set up the system call to run Anyplot. And then in the config file, we also have the input key, which contain what will be the input required by Anyplot from Volttron. So in our case, we're trying to set up the schedule called the AHU cooling, which basically define how we want to change in the temperature set point for the air hand unit operation. And this is really the how we define the message. So once we receiving the topic, which having the topic which is PNNL GLN AHU1, we were looking for the key called the zone cooling temperature set point. So then we are able to write the default set point in runtime through the message exchange. And then we also define output, which is what we were received from Anyplot simulation. So again, we were using the name and type to basically mapping the variable, which is kind of defined in Anyplot ideal file. And then we also having like the format we define for the message, which kind of mimic what will be respond from the building. And then once we having those kind of information, the variable and the socket CFG will automatically generated by Anyplot agent. And then we can basically using Anyplot agent, we should read the ideal file and the weather file to call the simulation. And then the command will start Anyplot agent, and then those config will be read by Anyplot agent, and then the socket server will handle the runtime data exchange. And this is kind of one plot to show how the agent and ePlot synchronize the information. So at the very beginning, Enterprise sending command to start the simulation. And then Enterprise internally will do the warming up to initialize the input variable. And then it will do the first time step with the default value to advance the simulation. Once it's kind of reached the first step, it will pause and then send all the information back to the message bus. And then once Enterprise get all the input ready, it will publish the message to the message bus.
Yeah.
And then
I think so.
yes.
Let me. Hey, Derman.
But Terry, sorry, we're picking up your conversation. All right, go ahead, Sen.
Okay. So once it's gathering all the information from other agent in terms of the input from for Enterprise, it will basically sending the information through the socket server to Enterprise, so that Enterprise with the input updated information can advance to next time step. And then it will doing the similar thing step by step until it receiving reach the end of the simulation. Once it's reached the end of simulation, it will send in the last information, and also the socket server will be closed, and Enterprise agent will be kind of released. And then Enterprise agents still alive, but then Enterprise, the software will be basically shut down. So if you want to start another simulation, you have to restart Enterprise agent so that everything will be repeated again. So this is just a very quick overview about Enterprise agent. I'm not sure if you have any question.
All right, thanks, Sen. Yeah, so a couple folks were asking about this before you got on. So any questions about this for Sen? Richard, did you have any questions?
No questions, actually. I've written my own simulation, so it's me just discovering Volttron. So this actually helped me a lot.
Okay, great.
Yeah, so this is based on, so although we call it Enterprise agent, but since it built based on BCDB, so theoretically it can also supporting other software as well, for example, Transys or Modelica. So you just need to basically customize the system call and also redefine the format for the input and output definition. So if you having like a software which kind of compatible with BCDB, you can do the same thing with the same kind of methodology I described here to integrate your software into Volttron environment.
Then a question on Energy Plus, the agent. Where is the source code?
So the source code is put into the GitHub. So if maybe very quick.
You're bringing up the site there.
Yeah, so if you search in the Volttron Enterprise, you will see there is a public releasable repo. So in this repo, it's not only having the source code, for example, the Enterprise agent, it also having like an example file to basically help you to understand how you can interact with Enterprise agent. For example, here we have like a shadow and the lighting control, which is kind of designed to coupled with Enterprise agent to do the closed loop simulation. And you can also find some kind of simple like documentation to basically show you how you are able to install the package and how you configure the software, and then how to run them with the standard Volttron command. And also it will list the desired output from the simulation so that you can understand if the Enterprise agent or Enterprise software working correctly in your computer or in your like setup.
Very nice. Thank you.
You're welcome.
Okay, any other questions? All right, if not, thanks a lot, Sen. If people have further questions on simulation, just let us know and we can direct your question to the right people. And if there's no other topics, then we'll call that an office hours. And in 2 weeks, we will talk about Elasticsearch, and Shweta will have results from the battery experiment that she had mentioned earlier.
And I have one question. How can I get to the today's presentation PPT resource?
Oh, the slide deck?
Yes.
Sen, is that part of a presentation that's already available?
Yeah, I think it already goes through the information release, so we can share that.
Okay.
Thank you.
You're welcome.
Anybody else want the slides? If not, I'll send it. Okay. All right. Thanks, everybody. We will see you in a couple weeks.
Thank you.
Yep. Thanks.
Thank you.
Thank you.
Thanks.
Bye.
Thanks.